MCP Server, MCP, or Model Context Protocol, is a standardized way for AI models to connect to external data sources and tools, like databases, APIs, or file systems. This thing just came out in late 2024, and it's already making waves in the AI world. So here's the problem it solves. Imagine you're building an AI assistant, and you want it to access your Google Drive, check your calendar, read your Slack messages, and search your codebase. Sounds simple, right? Wrong. Every single integration is custom work, different APIs, different authentication, different everything. MCP basically says, what if we had a universal connector? One protocol, and suddenly your AI can plug into anything that speaks in the language of MCP. It's like when USB-C finally lets us charge everything with one cable, except for AI tools. Let's say you're building a coding assistant. With MCP, it can read your project files, check your Git history, search Stack Overflow, and pull from your documentation. All done through one standardized connection instead of 5 different APIs duct taped together. The magic here is that it's standardized. Write an MCP server once, and any AI tool that supports MCP can use it immediately. No rebuilding the same integration over and over. RPC, or Remote Procedure Call, has been around since the 80s. But it's still everywhere, because sometimes the simplest solution is the best solution. RPC lets you call a function on a remote server as if it were a local function in your code. You don't think about HTTP or networks, you just call getUserData, and it happens. The concept is pretty simple. You have a function sitting on a server somewhere, maybe across the country. With RPC, you just call it like it's right there in your code. No messing with HTTP requests, no parsing, JSON responses. Just call getUserData function and boom, you get the data back. This is perfect for microservices. Let's say your shopping cart needs to check if a user is logged in. Instead of building an entire HTTP client and handling all that complexity, you just call authentication verify user function and you're done. Clean, simple, fast. Modern versions like gRPC even give you streaming and bidirectional communication, which makes it incredibly powerful for high-performance systems. SSE, or Server Sent Event, is honestly one of my favorites, and it doesn't get nearly enough love. Server Sent events let your server push updates to the browser whenever it wants, over a single HTTP connection. And it's beautifully simple. Here's how it works. Your browser makes one request, and instead of the server sending back data and closing the connection, it keeps it open. Then, whenever the server has new information, it just sends it down that pipe. Think about a live sports score app, or a stock ticker, or a notification feed. The server has updates and needs to get them to users immediately. SSE is perfect for this. And here's why I like it. It's just HTTP, plain old HTTP, which means it works through firewalls without any special configuration. No WebSocket protocols to negotiate, no special server setup. Even better, if your connection drops, SSE automatically reconnects. You don't have to write retry logic, and it supports event IDs. So when it reconnects, it can pick up right where it left off. That's really elegant. MQTT. MQTT stands for Message Queuing Telemetry Transport. It's a lightweight pub-sub messaging protocol designed for devices with limited bandwidth or battery, like sensors and IoT gadgets. Think of MQTT like a radio station. Devices subscribe to channels or topics, and whenever someone publishes to that topic, all subscribers receive the message. For example, a temperature sensor publishes to home/living room/temp, and your thermostat, your phone app, and your dashboard all get the update. You will use MQTT when building IoT systems like smart home devices, industrial sensors, or vehicle tracking where devices need to communicate efficiently over unreliable networks. The brilliant part is how lightweight it is. The absolute smallest MQTT message is 2 bytes. 2. That's why every smart home device uses this. AMQP. AMQP is basically MQTT's serious older sibling who worked in finance. It stands for Advanced Message Queuing Protocol, and it's all about guaranteed, reliable message delivery. Where MQTT prioritizes being lightweight, AMQP prioritizes never, ever losing a message. It's got message acknowledgements, persistent storage, transactions. It's like sending certified mail with tracking and insurance. This is what banks use, what healthcare systems use, anywhere where losing a message could cost millions of dollars. Suppose you're application processing a payment. You absolutely cannot afford to have that message get lost in the ether. AMQP ensures it gets delivered, and if something goes wrong, you know about it immediately. You can even group multiple operations into a transaction so they all succeed or all fail together. RabbitMQ is the most popular implementation, and it adds even more features like message routing based on rules, clustering for high availability, and a whole plugin ecosystem. Event-driven API. Event-driven architecture is less of a specific technology and more of a way of thinking about how services communicate. But it's super important, so stick with me. Traditional architecture is like a phone call. Service A calls Service B, waits for an answer, then does something with it. Event-driven flips that completely. Let me give you a concrete example. Like, you're building an e-commerce site. User places an order. In a traditional system, the order service would call the inventory service, then call the email service, then call the shipping service. If any of those are down, the whole thing fails. With event-driven architecture, the order service just publishes an order-placed event. The inventory service is listening, so it updates stock. The email service is listening, so it sends confirmation. Shipping service prints a label. Analytics records it, all independently. Nobody's waiting for anybody. Services don't even know each other exist. You want to add SMS notifications? Just create a new service that listens for order events. Done. Zero changes to existing code. Apache Kafka. Kafka is what happens when you take event-driven architecture and build it for planetary scale. This thing handles millions of messages per second, not thousands, millions. Netflix uses it to track every view, every pause, every rewind. Uber uses it for every ride request, every driver location update. LinkedIn uses it for every profile view, every message, every connection. But here's what makes Kafka different from a regular message broker. It doesn't forget. Traditional message queues delete messages after they're consumed. Kafka keeps everything for days, weeks, however long you configure it. Async API. Async API is like Swagger or OpenAPI, but for message-based systems. If you've worked with REST APIs, you know how nice it is to have interactive docs showing every endpoint. Async API does that for event-driven architectures. Picture this. You join a company and there are like 30 microservices all talking to each other through Kafka. Without documentation, you're reading source code for weeks, trying to figure out what messages exist and what they mean. With Async API, you've got a clean specification. It tells you exactly what events are published, what data they contain, who produces them, who consumes them. It's like having a map when you're lost in the woods. Is it glamorous? No. Does it implement anything? Also, no. It's pure documentation. But 3 months into a project, when you need to integrate with someone else's service and they've got async API specs, you'll be thanking every higher power you believe in. Thanks for watching, and I'll see you in the next one.